Now we will be understanding the quality plan for double glazing unit, and the standard is EN1279. So here the test parameter starts with thickness, overall thickness of the DGU. The standard what we follow is EN1279. The tool what we use to measure the overall thickness of the DGU is vernier caliper. Here, as it is a double glazing unit, it consists of minimum 2 panes of glasses, the first pane and the second pane. The pane of glasses can be either annealed or toughened or HS, annealed or laminated glass, annealed or patterned glass, toughened or HS or toughened or HS glass, lamination with laminated glass, laminated and patterned glass. So the combination of the panes can be any. So here we need to understand thickness tolerance. When the glass is of annealed combination, the overall thickness allowed is plus or minus 1 mm. When the glass combination is an annealed and a toughened or a HS glass, the overall thickness tolerance is plus or minus 1.5 mm. When the glass combination is annealed and laminated glass, the thickness tolerance shall be plus or minus 1 mm to plus or minus 1.5 mm. When the glass combination is annealed and a patterned glass, the thickness tolerance is plus or minus 1.5 mm. When the glass combination is a toughened or HS glass and toughened or HS glass, the thickness tolerance is plus or minus 1.5 mm. When the glass combination is a laminated glass plus laminated glass, the thickness tolerance is plus or minus 1.5 mm. When the glass combination is a laminated glass and a patterned glass, the thickness tolerance is plus or minus 1.5 mm. So, and the frequency of testing shall be once in 2 hours or every changeover. Whenever there is a change of thickness, then we need to recheck the thickness of the overall DGU. Next, coming to this thing, the second parameter is length and width. That is similar to the pre-process or tempering standard, that is EN1863 or EN12150. Next, visual inspections like scratches, chipping, edge works, all these are applicable as per the pre-process and tempering standards. Here we need to understand the few parameters, that is the washing machine brush quality. We need to check sealant mixing ratio, that we need to check the sealant mixing ratio. We will measure with respect to volume and by weight, 10:1 plus or minus 1. Here we need to check few test parameters, that is like shore hardness test. The tool how we follow is that with the help of shore hardness meter or a durometer we call, and with the, if it is a single part component, we use manual touch method. Next we need to check the desiccant filling, and in a particular linear meter spacer how much desiccant we need to fill, and in all edges we need to fill. Type of sealing what we are using, whether it is a vertical or a horizontal sealing. Curing, what is the curing and stacking, that we need to address. What is the delta T, that is what temperature difference, that we need to understand, and everything will be undergoing through the lab tests that are coming in the later sessions. We need to check butterfly test. Next we need to see the secondary sealant depth. We need to see how we are stacking, what is the labeling position, what is our logo, where we are using the logo, what is the labeling position. Primary sealant butyl, how you are keeping front and rear, coating surfaces, shining effect because of edge deletion, air gap, water, all these parameters we need to understand, keep in mind when we are processing a double glazing unit. Now we are going to see the defects that are going to rise in DGU process, that is a double glazing unit. We can see the defect is line marks, means lining on the glass surface. You can see the lining on the glass surface. The reason being because of poor water or because of the dirt on the rollers. We can overcome this issue by checking the water parameters like conductivity, pH and salt contents in the water, and clean the rollers with acetone on a regular basis. Next defect what we are going to get is deglazing, means the two glasses got separated. You can see in the figure the glass, one of the glass got fallen down. The reason being due to less pressure applied at the time of manual pressing. Normal pressure required is a 6 bar. Secondary sealant was not applied properly. We can overcome these issues by applying a pressure as specified by the manufacturer, and ensure uniform applying of secondary sealant along the periphery of the glass. You can see the dirt marks inside the DGU. You can see there is a dirt marks inside the DGU in the figure. The reason being the atmosphere should be free from any dirt, dust in water used for washing. We can overcome these issues. The room should be clean and enclosed, and room atmosphere should be free from dust. Water should be free of any dirt, and filter should be cleaned periodically. Next you can see the scratches on the glass surface. This is because of the brushes should have touched the glass without water. We can overcome this issue by we should never allow brush to touch the glass without water. First water should touch the glass and then brush should touch the water. Next one is poor edge deletion. You can see here in the figure the edge deletion, that is the edge deletion what we have done on the glass is not complete. If there is a poor edge deletion, you can see the traces of the coating. Our intention is the coating surface should be completely removed and the surface should be as good as a clear glass. This is because the reason being because of poor edge deletion and we can overcome this issue by properly doing the edge deletion and with the proper wheel to be used with the proper pressure. Next one is the non-uniform butyl application. You can see in the figure the butyl is like a zigzag line. Always the butyl should be straight and it should be continuous. The butyl acts as a moisture barrier. The reason being the zigzag line, reason being the non-uniform butyl application, and we can overcome this issue by applying butyl uniformly and continuously. Next defect what we are going to get in DGU is the poor sealant application. You can see there is a depth insufficient or there is a continuity missing in the sealant. The reason being because of poor sealant application. We can overcome this issue by maintaining a proper edge seal and the uniformity and tooling to be done once the pasting is done. Next defect what we are going to get is the condensation inside the DGU. That is the moisture is trapped inside the DGU. The reasons being desiccant is absent in the spacer, or the secondary sealant is absent in patches, or time delay between the desiccant filling and the secondary sealant applying at the end of the process, or proper sealing not done after argon gas is filled. We can overcome these issues by desiccant should be provided in the aluminum spacer, apply secondary sealing properly along the edges, time delay should be maximum 30 minutes, longer than the time delay, greater the chances of desiccant absorbing the moisture from atmosphere, and sealing should be proper after argon gas is filled. The next defect what you are going to get is the desiccants inside the DGU. You can see here the desiccants are fallen inside the DGU. The reason being avoid direct punching to the DGU. Generally whenever we go to any glass which is having desiccant inside, the major cause is you can see the DGU got drilled. So we need to avoid the direct drilling of the spacer. We can overcome this issue by air or gas filling. Make sure that the punches in the dia is less than the desiccant dia. Next defect you can see is the edge offset. You can see with the right angle there is an offset of the edge in the figure. The reason being individual glass size variations or improper pressing or wrong stacking method adopted. You can overcome this issue by both the glasses to have uniform dimensions, pressing to be uniform on all sides, glass stacking to be uniform, resting on the trolley, uniformly resting on the trolley. So now we will be starting the various tests that are applicable for an insulating glass unit. Let us start with butterfly test. The butterfly test we perform on secondary sealant. The secondary sealant is available in three forms in the market, that is insulating glass unit, structural glazing unit, and for weathering sealant. Now let us take the insulating glass sealant. The purpose of doing butterfly test is, as the sealant, secondary sealant is a two-part component, we need to maintain the homogeneity of the two parts of the sealant. And one of the test which is used to see the homogeneity in the mixing is the butterfly test. The procedure what we do is, first we will be taking a bead of sealant onto the piece of paper and we will be folding it and we will be trying to open. When we open, the shape of the sealant shall come like a butterfly. So that is why it is called a butterfly test. And if you see, if at all once you are opened the paper and you are able to see any white patches in the sealant, then you say that there is a mixing issue is there in the sealant. If there is no mixing issue in the sealant will come out to be black. So through this butterfly test, we are ensuring that there is a homogeneity of the mixing of the two-part sealant is maintained. Next test what we do is a desiccant test that we use inside the spacer to absorb the moisture. If you see here, the first what we do is, we'll be taking a 20 ml of water in a beaker. Next, we'll be measuring the temperature of the water. Then we'll be taking a 20 grams of desiccants and we'll be pouring the desiccants inside the water. And we'll be checking the temperature after the desiccants is kept inside the water. Within a fraction of seconds, the temperature will rise. Then we'll be calculating the temperature difference. That is, after adding the desiccant, what is the temperature minus initial water temperature will give me the desiccant temperature. And it should be minimum 32 degrees centigrade. You can see here the standard value for temperature difference is 32 degrees centigrade minimum. Next, we'll see the shore hardness test. The shore hardness test is used to check the hardness of the secondary sealant. The procedure what we do is, we'll be taking a 2-part sealant into a 100 by 100 mm square plate of 10 mm thick layer. Then we'll be applying a secondary sealant on the area of 100 by 100 mm square area, and after 24 hours of production, we'll be trying to see the hardness with the help of a shore hardness tester. You can see in the figure 3, we are keeping the shore hardness tester on the sealant and we are trying to measure the reading. If you are getting more than 30, then it is a good sealant. You can see here, as per the standard, acceptable value is 30 to 50 shore for secondary sealant. If you are getting below, means still it requires curing, and if you are getting higher value, means always there is a chances of getting the sealant as a sticky material. Secondary sealant should be act as a rubber material. Next, if you see, we have one more test known as spot life test or snap test. The test why we do is to have the curing. Snap time will determine the curing time and the curing rate. This test is to establish. You can see here the procedure what we follow is, first we will be taking a cup of sealant. Inside the sealant we will be taking a cup of first we will be taking a cup. Inside that we will be applying a sealant, and we will be taking a spacer and we will be inserting inside the cup, and we'll try to remove the spacer every 5 minutes. At a particular time it will not come out. We need to see here whether it is a cohesive failure or adhesive failure, and at what time. If it is tearing within itself and a particular time is, we need to note down that time. And the result is, for silicon the snap time should be minimum 20 minutes and the maximum is 60 minutes. Basically the snap time will determine the curing time between the glass and the spacer. Next test what we do is the parallelism test, that is known as to measure the overall thickness of the DGU. What we do is, first we will be placing the DGU vertically on at the edges, or at the center of the 4 edges we will be measuring the thickness of the glass. Generally the thickness of the glass includes the individual glass thicknesses and the air gap what the DGU is covering with. So if you see in the figure 4, we should be measuring the overall thickness at these particular areas A, B, C, D, E, F. And as per the standard, as we have seen in the standard, the thickness difference shall be plus or minus 1.5 mm is acceptable. Next test what we do for DGU is a dewdrop test. The procedure what we follow is, we will be taking a DGU glass, a final DGU product, and we will be placing the DGU glass inside the freezer. And we are going to freeze the glass minus 20 to 20 degrees centigrade for 2 hours. And with the help of a pyrometer, we will be measuring the temperature of the glass. If at all the glass is properly sealed with butyl continuity and desiccants, we will not find any condensation or dewdrop inside the DGU. If you are getting a condensation inside the DGU like figure 3, you can say that this is because of there is a failure of the butyl, that is the butyl is not continuous, or there is a gap between, there is a discontinuity of butyl. The desiccants what we place inside the spacer are not in a position to absorb the moisture. So here we need to, for dewdrop test, we need to find out 3 things. You can see in the result, no condensation should be there inside the DGU. Failure shall result in the bad quality of the primary sealant, secondary sealant and the desiccants. Next we will see silicon peel adhesion test. This is also one of the tests performed on the secondary sealant. If you see, we will be applying the sealant on a spacer and we'll try to remove the sealant. When the sealant is completely coming out, you can say there is a adhesion failure between the secondary sealant and the spacer. whereas in the figure B you can see there is a cohesive failure where some of the sealant is still sticking to the spacer. So with the help of a sealant, this peel adhesion test, we can measure the adhesion between the spacer and the sealant. Now we'll understand the tests what are all we do for insulating glass unit or double glazing unit. Generally, if you see double glazing unit, it is a combination of two glasses with air gap in between. As we are assembling two glasses with the air gap, the DGU glass acquires insulation property, insulation with respect to heat, insulation with respect to sound, thereby giving energy conservation parameters. If you see in insulating glass, apart from glass, there are many components which make up the DGU glass. Now we'll understand one by one and what is their importance and how all these parameters that are going to contribute to the combination of DGU will help in durability of the DGU and performance. Now let us understand each one by one. Corner keys. Corner keys must be dry and clean. Corner keys must fit tightly into the spacer bar. Shouldering or butyl injection of corner key is recommended. So now what are all we are going to discuss? These checklist will help us in making a durable long performance DGU glass. Spacer. The spacers must be clean, dry and free from grease. Spacer must be properly aligned on the glass. Desiccant. Proper amounts of desiccant should be used inside the spacer. Desiccant must be dry at the time of installation. Do not use already spent desiccant. Next, glass. Glass surface must be properly cleaned and free from fingerprints. Proper maintenance of glass cleaning equipment and solution is essential. Glass slides should have no edge defects or inconsistencies. Glass slides must be properly aligned with the spacer. Now let us understand PIB, polyisobutylene primary seal. Primary seal must be applied in a continuous uninterrupted bead free of void or skips. No excess PIB should protrude into the secondary seal cavity. Primary seal must be uniformly and sufficiently pressed to give an even thickness and good adhesion to the glass and the spacer surfaces. Silicon, the secondary seal. Multi-component sealants must be fully mixed and used at the proper mixing ratio. Sealant must be applied in a continuous uninterrupted bead free of skips or voids. Sealant must be tooled into position immediately. Now we'll see what do you mean by bite. Bite is nothing but the area that has to be edge removed or the depth of the silicon. The bite will give you structural strength. Strength with respect to wind pressure, strength with respect to thermal deflection, strength with respect to dead load or self weight of the glass. So basically the silicon will give you structural strength to the DGU product. Now this is how we are going to calculate the bite. Using the appropriate mathematical derivation, the following calculations can be used to determine the structural sealant bite, which holds the IG unit to the curtain wall mullion. Structural sealant bite is equal to, in inches, is equal to half of the smallest leg of largest light into wind load divided by sealant design strength. When it comes to IGU sealant bite, which is equal to 50% of half of the smallest leg of largest light into wind load divided by sealant design strength. You can see here when the sealant for IGU bite calculation and for the 50 by 50 load sharing, this is the formula what we are going to use to calculate the bite. Now we'll understand each test one by one what we do in DGU glass. Butterfly test. When you talk of a secondary sealant, it is the sealant what we use to make the insulating glass unit. It is a two-part component. That is, it is a mixture of base and hardener. So we need to have a proper mixing of the base and hardener that you are ensuring through butterfly test. The purpose of butterfly test is to verify the homogeneity in the mixing of the two part of sealant. If you see, place a bead of sealant into a piece of paper or cardboard, then fold the paper in half, smearing down the sealant bead, reopen the paper and visually inspect the sealant smear. When a pump is first started up, the smear will appear predominantly white. This is because the equipment lines should have been base purged at the previous shutdown. Continue to make sealant smers and inspect for white streaks. When the sample appears to be uniform in color with no white streaks, the sealant is fully mixed. The result is butterfly test should be performed with multi-component sealants at least every time a pump is started, if not intermittently throughout the day's production. As per the standard, no white sealant seen after cured, then the secondary sealant is accepted. If any white sealant is seen after curing, the secondary sealing, it is rejected. Next is desiccant test or molecular sieve test. The purpose of this test is to establish and maintain a document lab procedure for verifying the effectiveness of the desiccants. The purpose of desiccant is to absorb the moisture inside the DGU. In order to check whether the desiccants are in a position to absorb the moisture or not, first we will be taking a 20 ml water in a beaker. Then the temperature of the water with the help of a thermometer is checked. It is recorded as T1. Then we need to take a desiccants weighing 20 grams. Immediately add these desiccants into the water inside the thermometer and mix well. The temperature should rise more than 50 degrees centigrade within a 2 to 3 seconds. Take the final reading, that is T2. Calculate the temperature difference by using a below formula. The delta T is equal to final temperature after adding the desiccants minus initial reading, that is water temperature. That is delta T is equal to T2 minus T1. Start the production based on the result. The result is the standard value for the temperature difference is 32 degrees centigrade minimum. Compare the measured value with the standard value. For example, if my room temperature is 25 degrees centigrade and my desiccant temperature is coming to be 75, so 75 minus 25 will give me 50 degrees centigrade, that is delta T, and the minimum required is 32 degrees centigrade. If the measured value is greater than or equal to the standard value, the desiccants shall be accepted and in a position to absorb the moisture. When the measured value is less than the standard value, the desiccant shall be rejected. Next coming is shore hardness test. Through shore hardness test, we are ensuring the hardness of the secondary sealant. The purpose of this test is to check the hardness of the secondary sealant. What we do is, we will be pour the 2-part sealant into a 100 mm by 100 mm square plate to make 10 mm thick layer of sealant. Allow the square plate for 24 hours of curing. Keep the shore A instrument on the cured sealant and press. Note the reading from the shore A instrument. Standard. As per the standard, acceptable value is 30 to 50 shore A for silicon sealant. The measured value is compared with the standard value. If the measured value is within the standard level, it can be accepted. Otherwise, the sealant requires more curing. Next test is pot life or snap test. The pot life or snap test is performed to verify the mixing ratio is correct and whether the sealant is curing properly. The procedure for this one is, first we need to take a cup of sealant, then a piece of spacer is immersed inside the sealant. The spacer is pulled out every 5 minutes till the sealant tears cohesively and the time is noted. For silicon, pot life or snap time is minimum 20 minutes and maximum 60 minutes. So through pot life or snap test, we are ensuring the curing time. Next one is the parallelism test. The parallelism test is to check the overall thickness of the DGU. As the DGU is a combination of two glasses with the aluminum spacer, we need to ensure the overall thickness of the DGU, and that we are going to ensure through parallelism test. First what we will do is, we will take a DGU finished product and place it on a vertically. Then using the digital vernier caliper, we need to measure the thickness at the center of the 4 edges. As we can see in the figure, A, B, C, D, E, F, we need to take the average thickness. As per the standard, average thickness is allowed is plus or minus 1.5 mm. If the average thickness of the DGU glass is within the tolerance of plus or minus 1.5 mm, then it is accepted. If it is more than the tolerance, then it is rejected. Next one is the dew drop test. What we do to check the condensation inside the DGU. So we will be taking a DGU sample and keeping it inside the freezer at minus 18 degrees centigrade for 3 hours. Allow the freezer to freeze at minus 20 degrees centigrade, and after 2 hours take out the DGU sample from the freezer and check for condensation. Condensation can happen either on surface, outside surface, or inside surface or in between DGU. Outside or inside can be wiped out, whereas the in between DGU is a not okay. In that case, we need to check the primary sealant continuity, secondary sealant curing and hardness, and butyl and desiccant are in a position to absorb the moisture or not. So the failure of condensation results in the condensation should be no condensation should be there inside the DGU. Failure results in bad quality of primary sealant, secondary sealant and desiccant. You can see in the figure 1, the DGU glass is placed inside the freezer. Then it is freezed at minus 18 degrees centigrade for 2 hours. Then it is taken out to inspect for whether it is having any condensation inside DGU. Next one is silicon peel adhesion test. The purpose of this silicon peel adhesion test is to ensure the bonding or the adhesion between the glass, silicon and the spacer. So sealant gives the acceptable adhesion to the glass and the spacer surfaces. The procedure for this one is apply a bead of silicon sealant to the clean surface spacer, allow the sealant to cure for a specified time. After the specified time period, pull out the sealant and visually inspect for the mode of sealant failure. You can see in the figure, when I am trying to pull back at 180 degrees centigrade, it is the glass sample from spacer, it is an adhesive failure. The same thing when I am trying to pull out in the figure B, there is a cohesive failure where the PVB is tearing within itself. So an adhesive failure is a bad signs, whereas a cohesive failure is recommended. So we can see in the result also cohesive failure where the sealant tears within itself and remains adhered to the substrate is described versus desirable versus adhesive failure where it is completely pulls away from the substrate. Next test is the glass thickness test and air gap test. So you can see as it is a DGU glass, it is a combination of minimum 2 glasses with the air gap. With the help of air gap tester, we can say what is the thicknesses of individual panes as well as the air gap in between the DGU. So with the help of Merlin laser air gap tester, just we need to place the equipment on the glass surface and we need to identify. How we are going to identify means, I will be placing this equipment on the DGU glass. Once I press on the button, I will be getting minimum of 4 lights which indicates surface 1, surface 2, surface 3, surface 4. So when I am measuring from first line from right to left, first line to the second line it indicates the glass thickness, second line to third line indicates the air gap between the DGU, and third line to fourth line indicates the second glass thickness. So through this air gap tester you are able to check glass thickness as well as the air gap inside the DGU. Also this equipment can be used to measure the coating surface as well as if at all any PVB layer is present, that also can be traced through this equipment. So you can see if it is a single glazing unit, you will be getting 2 surfaces, thereby 2 lines. If it is a double glazing means you will be getting 4 surfaces, thereby 4 lines. If it is a laminated DGU means you will be getting 6 surfaces, thereby 6 lines. If it is a double lami DGU means you will be getting 8 surfaces with 8 lines. This is how you are going to trace out the glass thickness as well as the air gap inside the DGU. This concludes all the tests that we do for a DGU glass make. Now as we are using, actually if you see silicon, we have 3 types of silicons. One is known as structural silicon, second one is insulating silicon, and third one is weathering silicon. The silicon what we use in architectural system is the insulating glass silicon. Now this is a 2-part component, it is a mixture of base and hardener. So this is known as a butterfly test, which will determine the mixing ratio between the base and the hardener, that is the homogeneity between the base and the hardener. We will take a paper and we will take a small quantity of silicon, then we will fold. We will properly squeeze it. If we open, this is how a butterfly test will look. By the shape itself, we can say it is a butterfly. It is looking like a wings of the butterfly, and we need to see any white patches inside the mixing. If at all any white patches, the mixing is not okay. If there is no white patches, the mixing is okay. We have one more test known as skin over test. By placing your finger on the silicon, if you are able to feel the wetness, after 2 hours also we need to inspect. So if it is after 2 hours also it is touching, means there is mixing ratio issue is there. If it is not touching, means the test is pass. This is one more test known as spotlight or snap test, where what we are going to do is we are going to take a cup and inside it we are going to keep a silicon and immerse the spacer, and every 5 minutes we try to pull out this spacer, and at a certain time it will break cohesively. That time we need to note down. If you see, the start time for this spacer is 10:55 and the end time is 10:45. So the snap time is known as 50 minutes. So at that particular 50 minutes the silicon got cured. That is known as snap time. Now we are going to do one more test known as silicon peel adhesion test. This will determine the bonding or the adhesion between the silicon glass and to the spacer. We will cut a piece of silicon and we will try to pull out the silicon. If the silicon is coming completely, that indicates that is a weak bonding. If it is coming cohesively, means that is breaking within itself, means that is a good bonding. Now if you see here, it is not completely removed. The part of the silicon is still sticking to the glass as well as spacer. So this is known as silicon peel adhesion test. Always the silicon should have a elongation property. And when we cut also, it is not coming directly. So some part of the silicon is still adhering to the glass and the spacer. So this shows that the bonding between the glass, spacer and silicon is good. This is known as silicon peel adhesion test. Now you see, it is breaking like this. So there is no spacer visibility. As long as there is no spacer visibility and the silicon is sticking to the glass and the spacer, the silicon is of good quality. Now we are going to perform one test known as desiccant test or delta T test. What we are going to do is, we are going to take a 40 ml of water. We are going to take a 40 ml of water, and next we are going to take 40 grams of desiccants. Now we are going to take 40 grams of desiccants. With the help of thermometer, we are going to measure the temperature of the water. With the help of thermometer, we are going to measure the temperature of the water. You see the water temperature. It is 23 degrees centigrade. So you note down 23 degrees centigrade is the initial temperature. Now we are going to place these desiccants inside the water. You see here, focus here. You see, within a fraction of seconds, there is an increase in the temperature. Now you see, there is a temperature is getting increased. Now the temperature is 65 degrees centigrade. So our delta T will indicate. Now our delta T will indicate that is 65 minus 23, which is equal to 42 degrees centigrade is the delta T. Minimum required is 32 degrees centigrade. So once the desiccants, so this shows the desiccants are in a position to absorb the moisture. Now this is one more test to determine the hardness of the secondary sealant. This is known as Shore hardness tester. what we'll do is we'll be taking a Shore hardness tester and we'll be taking a silicon and we'll be placing on a glass with the spacers supporting. Now we'll be placing this equipment on the silicon and we'll see the hardness of the secondary sealant. You see it is coming 42. So the unit is 42 Shore A. The desirable reading is more than 30, more than 20. It should be in between 20 and 60 where we are getting 42 Shore A. So this test will determine the hardness of the secondary sealant. Next what we have is, so with respect to DGU we have seen butterfly, potfly. Now this is one of the in-house testing that is used to check the condensation or dew drop inside the DGU. What we do is, the purpose of this test is to check the condensation inside the DGU. We'll be taking a DGU sample and placing inside the freezer at minus 18 degrees centigrade for 2 hours. So through this test we are making sure that under extreme negative temperatures how the DGU is going to perform. If at all any condensation is there inside the DGU, whether the desiccants what we have seen in the shop floor are able to absorb the moisture, and any discontinuity in butyl that we need to see, and silicon is properly sealed or not that we need to see. So if you see there is no condensation formed inside the DGU. So this test will determine the properties of the performance of the desiccant, how the butyl is acting as a barrier to the moisture, and how the secondary sealing is protecting the surface and giving structural strength to the glass. Now we are going to see the one more test related to the final product of DGU known as parallelism test. As the DGU is a composition of two glasses and it is in between the airspace is there, we need to measure the overall thickness of the glass, because the glass can be heat strengthened or toughened or annealed, and in between there is a air gap is also there. So this parallelism test will determine the overall thickness of the DGU. Through the help of vernier caliper, I am measuring the overall thickness at different positions or the places of the DGU. You can see here the value is coming to be 24.71 at this particular area. The same thing when I measure on this thickness, it is coming 24.87. Now the same thing when I measure on the other side, it is coming 24.82. Now the same thing if I measure on the other side, we are getting 24.7981. So if you see the average overall thickness, it is almost remaining same. If you see the glass combination is 6 mm, 12 mm, 6 mm. So it should be 24 mm, whereas we are getting 24.7 on an average. As per the standard, plus or minus 1.5 mm is allowable. So through this test, we are assuring that the overall thickness of the DGU is maintained throughout the product. Now this is one more equipment similar to gas. This is one more equipment similar to gas known as toughened glass indicator. Now we are going to see whether the glass has been heat treated or not with the help of this toughened glass indicator. I am placing the toughened glass indicator on the glass surface and moving across the glass surface. We need to see whether any change in the color of the lighting. When I am moving across the glass, I am able to find there is a change in the color of the second line, which indicates the glass has been heat treated. Now, this is one more test to determine the properties of the base glass, what we get from a supplier. So, this is known as visual light transmission test.
If you see any glass like Saint Gobain, they will be keeping a remark as the nomenclature for a particular product is ST467. They'll give as a ST467. Here the ST indicates it is a reflective glass, and 4 indicates the color of the glass, which is green color, and 67 indicates the light transmission, that is the visual light transmission in the glass. So through this test we are ensuring the light transmission in the glass is 67%.